7.3 is about logarithmic functions as inverses. The logarithm is how you undo exponents. So everyone talks, well, how do you solve for exponent if you need to solve for the exponent? And the answer here is a logarithm. So when you have log of x base b equals y, you end up with if and only if b to the y equals x. What that means is with base b, I always circle the base, draw an arrow to my exponent. Logarithms always equal the exponent. That's how you do it. So what is the logarithmic form of each? When I'm transferring, remember, it's log of 100. Well, what's my base? Well, see how 10 is the base to the exponent, which is 2? That's always your base. Always equals your exponent. Log of 100, base 10 equals 2. Same thing here. Log of 81. What's my base? Well, the base of the exponent is 3. Always equals your exponent, 4. Example 2, what's the value of log of 32 base 8? Same thing, you can actually write that like log of 32 base 8. We don't know what that equals. It equals x. Again, what's my base? It's 8 to the exponent, which is x. So 8 to the x equals 32. Well, how can I get that? Well, I could try to guess that number. Probably punch in your calculator, find it somehow that way too. And we'll talk about that as we go. But the easiest way for now is just go ahead and factor it. Again, your calculator will factor it for you, but it's pretty easy to do by hand. 16 is 4 and 4, which is 2 and 2, 2 and 2. So that on the right is going to be 2 to the 5th. Why? Because there's 5 2's. What's 8 break down into? 4 and 2, which gives me 2 and 2. How many 2's is that? 2 cubed, and again, to the x power. Power to a power, you just multiply. So I end up with 2 to the 3x equals 2 to the 5th. When you have the same bases, you can just take their exponents and set them equal. 3x equals 5. Solve, divide by 3. X equals 5/3. Example 5 talks about how does the graph of y equals log of x minus 3 plus 4 base 4 compare to the graph of the parent function. Now we're starting to look at the graphs of these logarithms. And again, your calculator will graph them all, so I'm not real worried about that. But how it translates to the parent function is the important part. If I write the general form, it's y equals a times the log base b of x minus h plus k. Well, remember h and k being your vertex and absolute values and quadratics and everything else like that. We'll get back to it when we come to conic sections again. But remember, opposite in parentheses. So if I'm looking at y equals the log of x minus 3 plus 4, base 4, the base doesn't really matter. There's nothing in front, so there's no stretch or compression on it. Okay, so I just have this 3 and this 4. Opposite in parentheses. Well, minus 3, you would think that moves it horizontally left, but remember, opposite in parentheses, so the shift is really 3 right. And then outside parentheses, it's vertical, so plus 4 is 4 up. That's my translation.